All right, let's finish the back page of review worksheet 3 for the fall final exam. Okay, so just want to review the rule for absolute value functions and its derivative. Simply going to be absolute value of u is equal to u over absolute value of u times u prime. And the u value is just everything that is inside the absolute value bar. So in this case, for number 6, if we want to find the derivative for this absolute value function, the u value will be everything inside the absolute value, so simply x squared minus 4. And then we just step-by-step plug into our derivative rule. So u value being x squared minus 4 divided by absolute value of u times u prime times 2x. Okay. So here's our derivative. And if we want to evaluate the derivative at a point, we can just plug 1 into the derivative. Okay. We just have to be careful keeping track of the signs, and also to know that this denominator, whatever value we evaluate, we're always going to end up with a positive value in the denominator. Okay, so we get negative 3 over positive 3 times 2 is negative 2. And then part B, replace all the x's with negative 1s, so we get negative 3 over 3 times negative 2, which is positive 2. Okay, same steps with number 7. Okay, the only thing that's a little bit different with 7 is we have a leading coefficient of 3. And just like with any derivative rule, if we see any leading coefficient, we're just going to attach that to whatever we find as the derivative of the remaining portion. So that 3 will just attach itself to our derivative rule once we find our derivative rule for a derivative for 3 minus 2x cubed absolute value. Okay, and then part A and B, we're just plugging 2 and negative 2 into the derivative function that we found and getting the slope. Okay, moving on to linear approximation. So the idea behind linear approximation is simply that we're using a linear equation to approximate the y value of the function provided. Okay, so for instance, let's say we had a polynomial function, y equals f of x, and we're able to identify an equation of a tangent line at a given point, let's say at 1. Okay. Now, if we want to find the y value when x is 1.01, okay, we can plug into the original function, but if we plug 1.01 into the linear equation, we're not going to get an exact value. But as long as the decimal is pretty close to the point of tangency, then we should get a pretty good approximation. Okay, so the big picture with linear approximation is just taking the steps to find the equation of a tangent line, and then just plugging the decimal value into that tangent line equation. Okay, so just one step more than finding the equation of a tangent line. Okay, so the steps that we're going to take, we're going to find the derivative. We're going to evaluate the derivative at a point to find the slope. So we're just plugging the x value that's provided into the derivative to find the slope if needed. Sometimes the problem does provide this information already for us. Then we write the equation of our tangent line. And many times I like to get into slope-intercept form. That way I have everything else on the right side with y on the left. Okay? And then we just plug the decimal value into our tangent line equation. So for number 8, we're trying to get to the tangent line equation. So we already have the ordered pair here, 630. We have the derivative, and we can use the derivative to find our slope. Okay, and we're estimating 6.02 on the function. So we have the ordered pair already, so we need to find the slope. No need to find the derivative. The derivative function is already provided for us. So plug 6 into the derivative to evaluate it at a point so we can find the slope. The slope is 4. With the order pair 630, the slope is 4. Write our tangent line equation. And then I'm going to take the step to solve for y. So y is equal to 4x plus 6. Okay. And then the only step that we need to do now is replace the x with 6.02. Okay. Multiply this out by hand, and we get 30.08. So if we were to actually plug 6.02 into the original function, then the y value will be very close to our approximation. Is actually going to end up being very pretty accurate. Okay, pretty good approximation. Okay. Number 9 is much the same way. You have your ordered pair, but here we don't have to find the slope. They already tell us the slope. You just have to be able to know that this is referring to the slope. So you have your ordered pair, you have your slope, you write your tangent line equation, solve for y, replace your x with 3.02, multiply this out by hand, negative 12.08 plus 20, which is 7.92. Okay. Let's talk about the derivative of an inverse at a point. All right, so the idea is that there is a relationship between ordered pairs, between a function and its inverse, and there's also a relationship between the slope of the tangent line through those ordered pairs. Okay. And if we think about a function and its inverse, right? Function and its inverse is always going to be reflected over the line y equals x. Any ordered pair that you find on the function, there's also going to be a similar ordered pair, except the x and y will be flip-flopped. Okay, so if this ordered pair is 3, 1, then this ordered pair here, there will be a corresponding point on the inverse function where it is 1, 3. Okay, so ordered pairs will be flip-flopped. Okay, and the slope, however, the slope through these corresponding points are going to be reciprocals of each other. So visually, okay, let's say this slope, the slope of this tangent line through this ordered pair is 1/8. Then at the corresponding point of the inverse function, the slope of the tangent line will have to be 8. Okay, so at corresponding points between the function and its inverse, the slope of the tangent lines through those points will be reciprocals of each other. Okay, so let me just walk through number 10. We have our function. They tell us g of x is the inverse, and we're trying to find g prime of 1, given that g of 1 is equal to 2. So 2 got left off on the third line, but so some students missed that. So g of 1 is equal to 2. Okay, I like to create a table here with the first row representing the relationship between ordered pairs between the function and its inverse, and then the second row to show the relationship between the slopes through those corresponding points, okay, for the function and for the inverse. Okay, so we know that we know the ordered pair for g of x. G of 1 is equal to 2, and if we know that the ordered pair of the inverse function is 1, 2, then there must be a point on the original function where we have 2, 1. Okay, they told us that these are inverse functions of each other, so these properties must hold. Okay, we're trying to find g prime of 1. Okay, now the problem is that we don't have a g of x to be able to find the derivative and then to evaluate it. So we're going to have to go through f prime, okay, because we have f of x. So if we can find f prime of 2, then we can use that slope, take the reciprocal, and find g prime of 1 because of the relationship that we know these two slopes are going to share. So to find f prime of 2, we first need to go through finding f prime of x. So in this case, we have to find the derivative using quotient rule. So f prime g minus f g prime all over g squared. We simplify all that, and we get 5 over 2x plus 1 quantity squared. Okay. So we can use our derivative to evaluate. So plug 2 into your derivative function, and you're going to get 5 over 5 squared, which is 1/5. Okay? And if we know f prime of 2 is 1/5, then g prime of 1 must be the reciprocal of that, so 5. Okay. Let me just go over one more. Let's look at this last problem here. So g of f of x equals x, this tells us that f of x and g of x are inverses of each other. G of 7 is equal to 2, so I just arbitrarily chose this column to put g of x, so g of 7 is equal to 2. So that's the case, and I know that f of 2 is equal to 7, right? These order pairs must be switched if these are inverses of each other. Okay. What is f prime of 2 if we know that g prime of 7 is 10? So if we know that g prime of 7 is 10, then f prime of 2 must be the reciprocal of that, so 1/10. So that's going to be your answer.